Assalamualaikum warahmatullahi wabarakatuh, and we are from Group A. So today we will be doing a presentation on introduction of digital forensic regarding a memory forensic, and it is prepared for Dr. Fakaria Hani binti Haji Muhammad Ali. And this is me and my team members. I'm Nurul Ima binti Sarunizan with two of my other team members, which is Nurul Amira binti Khairuniza and Siti Nur Alia binti Faizul Anwar. So for today, the tools that we'll be using, there are two tools. The first one is a volatility, and it is to analyze the RAM dumps or memory images. And for the second one is we will be using dumpit in order to capture the contents of the system RAM. So we'll be carrying out the third task, which is to analyze the malware. So the first step is to identify the operating system, and this is to identify the machine's operating system profile in order to analyze the output to determine the OS versions of the Windows XP, service packs, and the architecture. So we'll be using the command, and we'll be run the command with python vol.py and -f malware.vramwindows.info. And by using this command, we are able to figure out the confirmation of the OS version used. Which is the first one is the line anti-major version is the fifth version were used, and the anti-minor version is the first version. And for the service pack, it is confirmed it will be used as the version, the third version of it. For the OS version, it is used with Windows XP Service Pack 3. Whereas for the system architecture, it is stated here, it is 64-bit and it is false. As it's already stated, it is false. That means the system architecture is a 32-bit system architecture. Thank you.
Assalamualaikum, my name is Siti Nur Alia and I will be explaining about our finding of infected process that we have found using the volatility framework tools. So once we confirmed the system was running on the Windows XP, the next thing we asked ourselves was where did this infection actually begin? And we didn't want to guess, we wanted to trace it properly. So the first thing we ran was a command called Windows PSP. Actually, this command tells us, this command will show us all the processes that were active on the system at that time. So while scanning through the list, one process stood out, which is the reader with PID 1640 here. And that actually raised a suspicion, but we still didn't know how it started. So in order to get a clearer picture, we decided to run a second command that for Windows PS3. So this tool is actually useful because it displays processes in a parent-child structure. Basically, it will tell us who launched who. So when we look at the bottom of the process tree, here, in Zoom, we could clearly see a connection forming. And this is the moment where everything is connected, where everything makes sense. Because we saw that explorer.exe with PID 1484 directly support reader.exe with PID 1640. Now, this is important because explorer.exe represents normal user activity like clicking file, opening folder. So this tells us that the malware execution begins when the user double-click a PDF file, because we can see this direct relationship between the explorer and the reader. Okay. Because of that, we were able to confidently identify this as the entry point of the attack. So This process change was a major breakthrough for us because it confirmed that the attack didn't come from a background system service or any remote network exploit, but instead it started from a compromised PDF file that was opened by the user. So once we know that, we can narrow our investigation to PID 1640 and use our forensic tool to uncover the code injection that will confirm the malicious activity. And that's all for me. Thank you.
Assalamualaikum, my name is Nura Amira. I will continue with the part on suspicious network connection. So for this part, our goal was to check whether the malware was communicating with anything outside the system. First, we tried to use command windows.scan. However, as you can see on the slide, the command could not run because the system is using Windows XP, which is not fully supported by Volatility 3. So, instead of stopping here, we use another approach. Next, we dump the memory of infected process with the PID 1640, so we could examine it manually. Okay, Volatility create a file called PID.1640.dmt. This line shows different parts of the process memory being copied into the dump file. This confirmed that the memory dump was successful and that we now have all the memory from the infected process. After that, we use findstr to search through the dump file for IP addresses. This is where we found the external IP address, which is 41.168.5.140, communicating to port 8080. This shows that malware had an active command and control connection, meaning it was communicating with an attacker. Next, we're moving on to how the malware hides itself inside the system. So we run the window.malfind command on the same process again on PID 1640 to look for suspicious connection. The result clearly show that malicious activity. We found a memory region which execute read-write permission. This is suspicious because normal programs usually do not need memory that can be written to and executed at the same time. So we also found that MZ header, which indicate a window executable file hidden in memory. This confirms that the malware use process injection when malicious code runs inside a trusted application like Adobe Reader. One more thing is we noticed that in the memory output is 000 value. In a normal program, memory usually contains actual data. So seeing a lot of 000 is unusual and suggests the memory was manually created or modified. This is another sign that the malware was trying to hide itself in the process. So overall, we confirmed that the malware was hiding inside the legitimate process and was also actively communicating with an external attacker. So that's all from me. Thank you.